Hello, this is Chuck Stull. What I want to look at today is firm size. Some industries consist of many small firms. Other industries consist of a few firms that are large. What I'd like to look at with economies of scale are some of the potential advantages of being large. Economies of scale are defined as lower average costs for large companies. This suggests that the technology exhibits increasing returns to scale, meaning bigger is lower cost. If we double the size of all the inputs, we get more than double the amount of output. Another way to think of this is that large firms are indivisible. If we break a large factory into many smaller factories, we won't get the same amount of output. What I'd like to look at now are several factors that contribute to economies of scale, or several reasons why we might have economies of scale. First, fixed cost may be indivisible. Consider a railroad shipping freight from Detroit to Chicago. It first needs to acquire right-of-way, lay rails and ties, put in the signals. These are all fixed costs that need to be incurred before they can ship anything. In order to ship, they will also need a locomotive and an engineer. All of these costs must be incurred in order to deliver one train car from Detroit to Chicago. So if we have a single car, all of those costs are borne by that one delivery. If we add a second car, the average cost drops by half. All of those costs are shared now across two cars. If we had 50 cars, we're going to have much lower average costs or much lower unit cost than a smaller train. So bigger is lower cost, or we would see economies of scale. Now, a railroad running dozens of 50-car trains will have lower unit costs than a firm with one train. The idea here is that the more we can spread the fixed cost across larger quantities, the lower the average cost is. So bigger firms, in this case bigger transportation firms, will have lower costs. This is an example of economies of scale. A second reason for economies of scale are setup costs. Setup costs are a special kind of fixed cost. These are often sunk. They're unrecoverable. Setup costs are costs incurred prior to production. They don't vary proportionally with quantity. That means if we have a large sale volume, we will divide the setup cost across more units, which gives us a lower average cost. Many creative industries heavily rely on setup costs. If we're a publisher or a studio, we find nearly all of our costs are up front. Consider a book. We start with market research, design, copy editing, writing the book, typesetting. These are all setup costs. Printing more books divides these costs. Similarly, software, music, movies, video games, the larger the quantity they sell, the more they will spread their setup costs, and the lower the average cost will be. This is true in research and development. Costs for a new pharmaceutical are in the hundreds of millions of dollars before starting production. If we can sell a large quantity of those medicines, the larger volume will spread the setup costs and reduce the average cost. So again, economies of scale, larger is lower cost. Specialization is another reason why we would have lower costs for larger firms. With specialization and division of labor, the classic example comes from Adam Smith, writing in 1776 about a pin factory. He compares a pin factory with specialization, with 10 people working, each specializing in a particular process: cutting the pin, pointing it, grinding it. Altogether, those 10 people could produce 48,000 pins, or 4,800 pins per person. Smith compares that to a single person working alone, doing all of the tasks without specialization. That person, Smith tells us, can produce only 20 pins a day. Right? The economies of scale are tremendous here. A huge, huge increase in production by taking advantage of specialization. So if a firm is too small to take advantage of the efficiencies from specialization, it will have much higher costs. Of course, we are far removed from Smith's day, but the same is true of specialized capital. Firms need to be large enough to fully cover all available equipment, to use all of the specialized equipment, or they're going to have higher costs. Dimensional economies are another reason that larger firms may be at an advantage, and this works in a very different way. This is a geometric relation comparing the volume to the area. So if we look at a pipe, the volume is going to be a cube, where the surface is going to be a square. That means if we double the diameter of a pipe, we will double the cost of material, 100% cost increase, but the pipeline capacity will more than double. We'll get 4 times the quantity that can be shipped through the inside. The volume will increase much, much more rapidly. So that means that bigger pipelines have lower costs. The same principle can be applied across many, many industries where we have that same geometric relationship. Right? The volume to area gives us more space for an increase in the surface area or the size we're producing. So if we look at chemical production, we can see these vats and towers are essentially pipes, and the bigger they are, the lower the cost is inside each of those. So we have more capacity to the cost of producing them. The same would be true for oil refining, for pharmaceutical production. Again, we can see, right, that same geometric relationship, the same dimensional economy saving. If we look at brewing, we see, again, a very similar capacity. Having a larger brew kettle will produce at a lower cost because of dimensional economies. We can even look at this for an airplane. An airplane is essentially a tube on wings. The bigger the plane, the more capacity we have inside for passengers, so that a large wide-body jet will have a lower average cost per passenger than a small regional jet might have. Reserve equipment is a final reason that we'll look at for economies of scale. Many industries need to maintain backup equipment in the case of failure of critical components. So let's consider electrical generation. The smallest plant would need 1 operating machine, but in order to maintain reliability, they will need to keep a second machine in reserve. This is the reserve equipment. That gives us a 1-to-1 cost of reserve equipment to the operating equipment. If we were a bigger electrical generator, maybe using 2 machines, we could still have a single machine back up our 2 generators, since it's unlikely they will both fail at once. This will reduce our reserve equipment cost by half, and again, make it cheaper for a bigger company to operate. If we were a big electric generator with 10 machines, 1 backup may still be enough to ensure the quality of our production, and our cost would be 1/10 what they were in terms of the reserve equipment cost. And again, bigger is better. So economies of scale give us one explanation why size matters, one explanation why we see large firms in the real world as opposed to the small atomistic companies of perfect competitive assumptions. So we have economies of scale. Big firms have lower costs, and small firms will operate at a disadvantage. This is Chuck Stull from Kalamazoo College. Thank you.